Hello everyone, and welcome back to another video. This has to be like the 6th retake of this, because always something happens or I'm not satisfied with how the video turns out, but yeah, let's hope that this is the one that makes it to YouTube. So, what you're looking at right now is a graphics card that has caused a lot of pain, but also excitement in me. Because this card, while being an asshole, is a very, very good overclocker. So this is the GTX 680 that I got with the 780 Twin Frozer. That is right over here. Still hasn't changed much. I haven't really worked on it because most of my attention went to this card. And yeah, so I got this together with that 780, and there was a pretty good indication what was wrong with the 780. There wasn't an indication of what was wrong with this. So both of these cards were advertised as dead. But there was no mention whatsoever what's actually wrong with this card. So basically I just bought that because I just wanted the 780. This one was just a bonus, which is a very, very good bonus as it turns out. So yeah, I got this card, and when I got it I disassembled it and kind of checked for problems, and you can kind of see the card has already gotten some modifications. And basically what I found is there was a short circuit from the memory rail to ground. So first I suspected that maybe a low side MOSFET was shorted, but then later I found out no, the MOSFETs are fine. It's actually something behind the output of the VRM, which, no, technically the low sides are also there, but whatever. In the end it was a couple of multi-layer ceramic capacitors behind the memory on the back side, because as it turns out someone else tried repairing this card before. So I assume originally the card had a couple of knocked off capacitors, and someone tried to replace those knocked off ones. Sadly, that person seemed to have used either very bad soldering skills or just straight up bad capacitors. And pretty much all of those that were manually added to the card were shorted. So I removed them all, and then the short was gone. The memory rail went from a resistance of 1 ohm to around 170 ohms, if I remember correctly. I did put some other capacitors on here. You can see these were manually soldered by me. I didn't replace all of them. There's still some empty pads, especially for the very small capacitors. I haven't replaced these because, well, the memory overclocking is still, like, the card still runs stock and it even overclocks the memory, so it doesn't really need the capacitors, though I might get a couple extra megahertz out of it if I add them. And yeah. And then there was a second issue with the card, which involves this thing. So there was a regulator over here, which I presume is the PEX rail. This could also be the PEX rail, but this is not like, I had a 670, which died, that did have this circuit, but it didn't have that. And since every card needs a PEX rail, I think this is the PEX rail and this is something else that's extra. And yeah, so this regulator had problems. And the problem was, like, basically what happened was, out of 5 boot up attempts, the card would boot about once. And whenever the card booted, this regulator would spit out a fluctuating voltage between 1 and 1.5 volts. And when the card wasn't booting, this was sitting locked at 0.65 volts with the power good signal of this regulator pulled low. So this regulator was unhappy about something. So my solution to this was to take one of these DC to DC buck converter boards that I had, and yeah, connect it to 12 volts up here at the memory VRM. This is the input filtering, and this is set to put out 1.25 volts, which is sort of in the middle of that voltage that this was putting out, and the output just goes to these two multi-layer ceramics that were the output filter of this regulator. Now with this, the card pretty much boots up fine most of the time. Sometimes I'm running into another issue with this thing, which is that sometimes this just doesn't turn on. Like sometimes, or like it turns on and then when Windows boots it shuts off. And I think that's why, I think the reason why is this thing is only rated for 4 amps. So at 1.25 volts, that's like 5-6 watts. I think there's a chance that this is pulling more than that for like when the card boots up and like hits full clocks for a minute and stuff, like a big transient occurs. This might have some, like this is a pretty basic board, but this might have some security stuff so that when it's drawing too much current, it just shuts off. But most of the time, this is booting up fine. The reason why it's removed is also because I wanted to troubleshoot that, so I removed it from the card and tested it on a external power supply. But yeah, this works most of the time. Then I went to mod the card because like at that point I recorded the shot. I recorded the shot before this thing was on the card. I still recorded it when the card still had that 1 out of 5 boot attempts was successful thing. Yeah, and in that condition the card already did over 1.3 gigahertz on the core, which, considering this is a reference PCB with the reference cooler and the reference BIOS, this is really good in my opinion. So I was like, this might potentially be a really good overclocker, and as it turned out, yes, it absolutely is. The ASIC quality on the core, if you're wondering, is better than 91%. So yeah, really high ASIC quality. And yeah, so I started modding. I attached these yellow capacitors. There's 3 on the memory VRAM. The third one is under the baseplate here. And then, which you could have seen already, these 6 on the core. These are the only capacitors I added. I could add a lot more capacitors, which I will probably end up doing. Like some can types on the multilayer ceramic row over here, then multilayer ceramics behind the core and at the memory, and that sort of stuff. And then I added a volt mod to the core. I think this is a 50 kilo ohm potentiometer, which, yeah, the soldering on here is very, very delicate. If something pulls on this multilayer ceramic on the PCB will be ripped off, which is why I have to be very careful with this. Memory is not volt modded yet because that controller is on the front under this base plate here, and it's also one of those Ridgetech controllers that have like only a product code on them, not the actual name of the part. So I need to decode that first, which can be annoying. So that's why I haven't volt modded in memory yet. But yeah, so I also sawed the base plate in half, as you can see, because the water block that I was using this with didn't fit with the baseplate portion around here still present. So I had to remove this, sacrifice memory cooling in the process, though I have 2 140mm Silent Rings 3 fans at full speed pointed at the card at all times when I'm running it. So I was testing with like touching it, and it wasn't getting hot. Even the VRM, even at like peak voltage, which I'm going to get to what I ran this with, wasn't getting all that hot. So yeah, let's get to overclocking then. So I've already said that this thing is an amazing card, and it really is. So when I got the GTX 780 Jetstream and got it to 1437 MHz, I already thought, okay, this must be an amazing core. Yeah, this thing kinda outclocked that by 70 MHz. This thing hit 1502 MHz on the core, on a reference PCB. Which is like, yeah, that's straight up beating some extreme overclocking cards. So I did upload a run in Firestrike that I made to HW board, and this card is number 14 out of 134. And that's including all the LN2 and Dry Ice cards. That's like all the 680s on HW board in Firestrike. This is number 14. And I just ran it with water, even with reused thermal paste. Like, if you just put a lot of thermal paste on the core and it spills out to the side, this can actually help with thermal transfer. I didn't even do that. And yeah, it still did number 14. Actually, I would have gone up at least one more step, because number 13, I checked, actually had a lower CPU score and also had lower clocks. It's just that guy had a 2700X and I'm running at 8700K in my test bench, so my CPU score was about 6,000 points lower, which meant that my overall score was also slightly lower than that guy, even though my graphics card was faster in every... actually, I think that guy ran higher memory, but my graphics score was higher. So, yeah. Also, I forgot to mention there is a custom BIOS on this card. I used Kepler BIOS Tweaker to extend the 225 watt limit that this ships with to 900 watts. So I'm not gonna be hitting that anytime soon, because before I hit 900 watts, my 750 watt power supply will probably shut off. So yeah, and since I made that, there's no longer, like, the voltage isn't fluctuating around, the clock is no longer fluctuating around, I'm getting a steady line and steady performance. So yeah, this card is really good. Like, crossing 1500 megahertz on Kepler, I thought you need like sub-ambient for that, and that like, this is just on normal water cooling. Oh, and I didn't go into the voltages. So I ran 1.35 volts behind the core. That is a not inconsequential amount of voltage. That's actually more than I would like. I mean, I was like 1.3 is probably what the VRM can handle. 1.35 is kind of pushing it. And yeah, so I won't be going to 1.4 because I think that would just overstress the VRM, because like power consumption and current is a quadratic with voltage. Like, you don't get a linear increase, it is quadratic, and in like after 1.35 you just shoot up like madness. So yeah, I don't think that this reference 4-phase can take it. Like, I'm already beating cards with an 8-phase. That other guy that's one place before me had a 680 SoC. So that's the super overclock card from Gigabyte. And that has an 8-phase with, was it 50 amp or 60 amp power stages? I don't know. But like, that's an 8-phase. This is a 4-phase. And then like my output filter, like pretty much the output that the card chips with is this. And then the mozzarella ceramics on the back, like the SMD capacitors, those I added by myself. Which this helped about 1 tick, like one 13 megahertz step, because Kepler goes in 13 megahertz steps. So, yeah. The core on this thing is amazing. Sadly, the memory is not really that good. So this card has Hynix MFR. I have encountered MFR before, so it's also worth saying that this is 2 gigabit AFR. And yeah, I had 2 gigabit AFR before on my 7950 and my 7970 Lightning. On both of these cards, these memory chips did not scale with voltage. Which, if something doesn't scale with voltage, it usually doesn't scale with capacitors as well. I didn't actually properly test memory clocks on this, so it could be possible that this also didn't scale these capacitors. So the maximum I was running was a 500 megahertz offset, which then was 3500 as reported by MS Afterburner, or 1750 something in actual DRAM clock. So this was not all that fast. Maybe overvolting is gonna do the trick. Like, just because you have the same memory modules doesn't mean they absolutely have to behave like other memory modules of the same kind. Because I've had that before. I had a Hynix 1 gigabit AFR on one card that was absolutely craptastic, and then also Hynix 1 gigabit AFR on another card that had the same PCB, and that card, it like scaled with voltage, it like clocked pretty high actually. So maybe this will also increase with voltage. Like, the big problem is on 28 nanometer card in my region, it seems to be almost impossible to get Samsung chips. I had one Samsung card, and that card is dead because there was a 670. But that card did like 4 gigahertz memory, like it did another 500 megahertz and on top of this. Or didn't I actually think it... I mean, I think it did 4 gigahertz like briefly, but only really reliable like 3800 or something. But still, that's a lot higher than this. And every single other 28 nanometer card, and I have a fair amount of 28 nanometer card, it's actually approaching Or maybe I have actually the same amount of 28nm card as I have Fermi cards. So I have a fair number of 28nm cards, and that's counting the AMD ones. Not a single one of them has Samsung memory. I have, like the low power ones, I have a 7770 and a 650 with Elpida, but every other 28nm card I have is on Hynix. Not all MFR, I have some AFR cards as well, and AFR seems to be scaling with voltage, at least on the 7970 matrix. But yeah, Hynix for 28nm just seems to be what was floating around in my region. It's not that great, because Samsung on 28nm, I don't know what memory revisions are floating around for Samsung, but they all seem to be pretty good. So yeah, that's like the thing that's probably gonna bite me in the ass at some point. Because it was the same with the 780 Jetstream. That one also did only plus 500. That card has AFR, I think. So that has a higher chance of scaling with voltage, because I've observed that. I haven't observed it for this memory chip. But the overclock was the same on the 780. It also was 3500. So, yeah. Then... yeah, let's talk a bit about what's next for this card, because I absolutely want to run this more. I want to see this go even faster. And what I'm gonna do is basically attach all those capacitors that I was talking about, so... put a couple of can types on this row of multilayer ceramics. Put multilayer ceramics behind the core. Put multilayer ceramics on the memory. And all that stuff. And then... well, memory volt mod as well. And after that, I have decided that I am now getting a dry ice capable pot, and dry ice and like acetone, and like K-type thermocouples and all that stuff. So I'm now putting it on the list for soon-ish to get a dry ice pot, because I want to run dry ice. It's not gonna be liquid nitrogen, because I can't afford a DWA. It's like, I can maybe afford a pot if I get like a super cheap one or a used one. I can't afford a DWA for liquid nitrogen, because that's like even more expensive. So that's why I'm going dry ice first. But I do want to do dry ice. Like, I think if... actually, I don't know if the VRM will survive dry ice. Like, so I've gone in, like, I haven't looked at what exact MOSFETs this has, and I haven't looked at the data sheets, of course, but I was like, assuming every low side MOSFET in this VRM can handle about 30 amps. I've got 8 low side MOSFETs in this VRM. And in terms of power consumption, like, since I just modded the BIOS instead of removing the monitoring chips, I was still getting a power reading in GPU-Z. And GPU-Z was reporting a maximum power consumption of 550 watts, though I think that reading is actually wrong, or maybe just a very high spike. Because when I was checking the actual time graph in GPU-Z, it was reporting pretty exactly 300 watts of power consumption in Firestrike. And assuming the 30 amp limit at 1.35 volts, yeah, I would have 324 watts, if I remember correctly, until I go out of spec or like overstress the MOSFETs, and I'm already at 300. Which actually, well, if you cool things down, they draw less current, I think. I'm not super sure about that, but I think I heard about that. If you cool things down, they draw less current. So maybe taking the super cool will actually help that situation, but I will very obviously increase the voltage further, and that's quadratic. I think the cooling down thing is more linear, so I will end up drawing more current actually. But then again, if you cool MOSFETs down, their current capability increases. So I'm just gonna trust my power supply that if a MOSFET blows up, which usually actually is the high side, I haven't blown up a low side yet. I only had one that was kind of faulty on a 580 Lightning. But every MOSFET I've blown up by like modding a card or overclocking it was always a high side. So yeah, if this blows up, I just hope that my power supply will just like trip protection immediately, because it did that before. It has a very fast protection from what I've seen. So yeah, and if this blows up, it's gonna... I'm not putting the e-power 5 on this because that's going on a big Kepler. This is a small Kepler, it's a GK104. But I am probably going to put one of these on it. So this is a 6-phase from a GTX 580. That's, well, pretty much this VRM plus 2 phases. So this should be powerful enough to run the card at... Yeah, I think that's gonna be enough for dry ice. The only problem is that 670 that I talked about that died. Well, it died while I was trying to attempt to e-power it. So while I was e-powering that 670, the PEX rail on the back... Oops, sorry, I bumped the camera stand. The PEX rail, which actually is e-powered on this card, so this might not actually be an issue. But on the 670, the PEX rail started putting out way above 2 volts when I removed the V-Core VRM and controller. So that's how that 670 died. Just like more than 2 volts to the core. Yeah, that's dead. So here it is e-powered, which means this might not be an issue, but there's still a problem, which is I still need to get the memory working with the stock VRM. Because the 580 board right here, like, it has the memory VRM still on it, but I haven't figured out to get it working yet. Like, I think I saw someone on the internet who had a 480 power board, which is pretty much exactly the same PCB as the 580, who had the memory rail working, but I lost the link, and I don't know how to find it. So, yeah. Yeah, so that's pretty much the problem. I need to get the memory VRM working on this, because I can only e-power core. I can't e-power memory. Yeah, that's kind of a problem. But I might not actually have to risk this card all that much, because I have actually bought another 680 reference card, which also equally didn't have any description of what was wrong with it, other than PC turns on and no picture. So I already know there's no major short on this, because there's no fuses on this board. And when the PC like doesn't turn off immediately, you know that like there's no short, no major short. So the other 680 probably also has like a memory, a voltage rail not working. I don't think it's a dead core, because usually you get like a picture, but then it crashes on driver install, or you just straight up get artifacts. So I think that other 680 also just has a dead minor rail, or maybe major rail, or maybe something. So once I get that other 680 working, which I don't know, it's not a guarantee that I get it working, but I am optimistic. So yeah. When I get the 680 working, I can use that to test. And then once I know the things work, I can do the mods on this one. Because I don't think the other 680 will have a better core than this. Like, this is pretty much the peak already. Like, again, this is a reference card. This has a 4-phase VRM. And I am outclocking a 680 SoC, which has twice the VRM. And also like a proper output fill. Like, the SoC is one of the... I don't know if it's the best 680, that's probably the Lightning. But like, it's the top-end card that Gigabyte made, and it's like a pretty good PCB. It's a lot better than this thing. So yeah. But I am overdrawing my usual 20-minute limit by a lot now. So yeah, I think that's pretty much it on this card. Yeah, I'm absolutely going to run this more. It's just that I have an exam this week, and there's another one coming up sometime later. So I don't really have that much time to spend on things. In fact, I'm going to go to learn for that exam right after making this video. So I don't exactly know how much time I have for things, but yeah, I really want to run this more. This card is amazing. So yeah, thank you for watching. I hope you enjoyed, and until next time, goodbye.